Hello everyone, thanks for tuning in to our intensive physics virtual lessons. We're going to continue our studies in Chapter 7 on universal gravitation. Last class we talked about how satellites move around the Earth through space in these things called orbits. Today we're going to learn about how much time it takes for that object to revolve around that other object. So in this case, this image is of the Earth making an orbit around the Sun. This orbit or revolution, of course, takes 1 year to complete. However, other satellites, their times vary depending on how far away they are from the Earth. We can calculate this from this equation that we pull from the book. Period, symbolized by t, is equal to 2 times pi times the square root of r cubed over g times me. So we see some familiar faces in that equation. We can remember that me stands for the mass of the Earth. It's equal to 5.97 times 10 to the 24 kilograms. G, of course, is our gravitational constant. It's equal to 6.67 times 10 to the negative 11. R, of course, is the distance between the 2 points, between the object and the thing that it's orbiting. Okay, R actually stands for the radius of the orbit. Okay, so if it's a perfect circle orbit, we get the letter R from the radius. But it still means the distance between the 2 points. We're going to do a little bit of a practice and use this simple equation to determine the period in hours of an object orbiting Earth that's 65 million meters from the Earth's center. So, sort of like last time, I'm going to go ahead and write our equation on the board. Great. Next thing I want to do is I want to look through the question and see if there's any known variables that I can write down. So I see that the distance from the center of the Earth, or R, is 65 million, wrote that a little big, meters. Okay, I'm looking for the period, so I'm looking for t. And I know that g is equal to 6.67 times 10 to the negative 11. And I know that the mass of the Earth, or me, is equal to 5.97 times 10 to the 24 kilograms. Let's make sure we put a unit on these guys here. Like I said, g, there's a lot of units there. I think we can ignore that. We've done the math enough times. So it looks like I have enough information to go ahead and solve for t, period. So I'll go ahead and fill that out. Always good to include units in the substitution. And when I put this lovely looking math problem into my calculator, I end up with t is equal to 165,006. Now, my units for this are actually in seconds. Okay? Depending on what the question asks, actually I kind of jumped the gun there, depending on what the question asks, this might be an acceptable answer. However, it looks like we want to know what the period is in hours. We're currently in seconds. Okay, so all we need to do is take this number and divide it by 60. And that gives us 2,750.1 minutes. Okay? Almost there. If we take this again and we divide it by 60, I'll have to bring my work up here. We get that t is equal to right around 45.8 hours. And it's a little messy, but make sure to circle your answer. So it takes 45.8 hours, about 1.91 days, for a satellite 65 million meters from the center of the Earth to orbit around it. Thanks for tuning in, guys. Look forward to seeing you next video lesson.